Welcome to Hartman Math. Before we get to some new trigonometric identities, let's go ahead and review the previous lesson, solving some trig equations. In this case, we're going to be solving on the interval 0 to 2 pi. Go ahead and pause here until you're ready. All right, so number one is a multiple angle problem. So even though our interval is 0 to 2 pi, we are going to have to explore the plus 2n pi idea, as if we are talking about cosine. But let's isolate cosine of 3t first. And then let's think on the unit circle, where is cosine of some angle that will be 3t? Where is that negative a half? Where is the x-coordinate on the circle negative a half, where we're left short and then long going up or down? We're talking about 2 pi over 3 and 4 pi over 3. So 3t equals 2 pi over 3 plus 2n pi, 4 pi over 3 plus 2n pi. Let's solve for t, divide by 3 here and here. Probably a good idea to kind of maybe convert this to 6 pi over 9 so that then we can start substituting in 0 for n and 1 for n and 2 for n in both of those. And those are the solutions that we should get. All right, number 2, maybe explore sines and cosines. If you do that, this becomes cosine over sine. And then we need to add these together, so we need a common denominator being sine x. So with sine x, we need to multiply top and bottom by sine x. We are here. Pythagorean identity right there. 1 over sine x equals 2. We take the reciprocal on both sides. We get sine x equals a half. And where is that going to happen? Pi over 6 and 5 pi over 6. Is where the y-coordinate is a half. This is lesson 5.4, the sum and difference formulas or identities. So if we're talking about sine of an angle plus another angle, u and v, sine works out to be sine of u times cosine of v plus cosine of u times sine of v. Here's the difference formula for sine. Cosine's a little different. It's got cosine times cosine, and then that sign is opposite of that sign. And then tangent, again different, works out to be a quotient of, and we thought of distributing, it definitely doesn't distribute, but tan of u plus tan of v on top divided by 1 minus the product of those tangents. And then with this being a minus, that's a minus, and that's a plus. So make sure you have access to those formulas. Example number 1, find the exact value of the cosine of 105 degrees. So we need to think in terms of our unit circle in degrees and see if we can create 105 using addition or subtraction of the key angles that we know. And our key angles are 0, although that's not going to help here, 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees, 120 degrees, 135 degrees, and so on. So how do we create 105? Well, there's definitely multiple ways that we can do it. But probably the simplest way is that it's the sum of 45 degrees and 60 degrees. So this is our u, and this is our v. So cosine u times cosine v minus sine u times sine v. Now we start thinking in terms of unit circle. X-coordinate 45 degrees, root 2 over 2. X-coordinate at 60 degrees, 1/2. Y-coordinate at 45 degrees, root 2 over 2. Y-coordinate at 60 degrees, root 3 over 2. And then the nice thing here is if we kind of multiply these together, they do have a common denominator of 4. The numerator is going to be multiply root 2 minus root 6. There we go. Now, both WebAssign and the back of the book are going to have slightly different answers that will be equivalent. Both will accept this. Example number 2, find the exact value of the tangent of pi over 12. Same idea. Can we create pi over 12? Now we're talking about radians from the angles that we're aware of in the unit circle, like 0, pi over 6, pi over 4, pi over 3, and so on. Okay? Well, we kind of think there's actually multiple ways of doing this. Pi over 4 is 3 pi over 12, and pi over 6 is 2 pi over 12. And if we subtract those, we get that. Also, it's pi over 3 and pi over 4. So either one of those works. So either one is going to get us the pi over 12. This one is particularly 4 pi over 12 minus 3 pi over 12. The other one works just as well. So now if we go in terms of the formula, it's going to be tangent u minus tangent v over 1 plus tangent u times tangent v. So now let's think about this one. So this one here, we're talking about the coordinates being x coordinate 1/2, y coordinate root 3 over 2. So when we take the y divided by the x, 2's are going to cancel. We're going to get root 3 over 1. So that one's root 3 minus 1. Multiply root 3 and 1. So here we're going to get, as we simplify, the square root of 3 times 1. We just went from unit circle is going to be 1 plus root 3 on the bottom. Then we want to fix the denominator, so we're going to do the conjugate. Remember, that's going to be essentially gone there, as we're talking about just 1 plus root 3. So the conjugate is 1 minus root 3. We multiply top and bottom. So we're talking about now distributing. And when you distribute and combine like terms, on top you get negative 4 plus 2 root 3. On the bottom you get 1 minus 3 is negative 2. Now let's do the division. We got negative 4 plus 2 root 3 over negative 2. If we divide here by negative 2, we're going to get positive 2. Divide here by negative 2, we're going to get minus root 3. And there's our final answer, fully simplified. Example number 3, instead of kind of maybe having an angle to work with, we get some clues. So we want to do sine of u plus v, obviously going to use the formula. And here's what we know. Sine of u is 3/5, so that's going to be helpful. Tells us the quadrant that u belongs in as well, via a hint. And then tangent of v, and then the quadrant for v. So what we want to do, since this is going to require sine u, cosine v, sine v, cosine u, all that, is we need sketches for both of these. Sketches where we're in the correct quadrant. So we're talking about quadrant 1, sketch a right triangle in quadrant 1. When we sketch a right triangle in a quadrant, we always want one side to be on the x-axis, opposite hypotenuse. There's our sketch for angle u in quadrant 1, opposite hypotenuse, missing. So we're going to need to go find that by the Pythagorean theorem. We should be able to get that that's 4. And then over to our sketch here, between pi and 3 pi over 2, we're talking about quadrant 3. In quadrant 3, all the coordinates are negative. So we're going to get a positive here because that's a ratio of dividing. So opposite and adjacent, but they're going to both be negative. So here's our sketch in quadrant 3. Again, we're going to need to do Pythagorean theorem. I think we're going to come out to be 17. Now when we do sine u plus v, here's our formula. Now be very careful as you go writing this. If you were to write this and submit your written work, sine of u is not the sine of 3/5. We don't know angle u. We're not going to need to know angle u. We just need to know the sine of u. It's 3/5. So write down 3/5. Don't write sine of 3/5. It's 3/5 times. Now we go over here. Cosine, negative 8 over 17. Plus cosine u, 4 over 5. Sine v, negative 15 over 17. So our numerator is going to be negative 24 plus negative 60. It's all over 85. We get negative 84 over 85, the final answer. Example number 4. more of a calculus kind of idea here. Write this as an algebraic expression. Remember, arc sine x, we're talking about finding an angle. Arc cosine x, we're talking about finding an angle. And it's unfamiliar, so we're going to go sketches. Here's our u, here's our v. We're going to write sketches for these. So we're going to sketch, if we think of this as being x over 1, sine opposite x, hypotenuse 1. And same thing over here, different sketch, adjacent x over hypotenuse 1. So we want some sketches. All right, so here's our sketch for angle u, opposite x, hypotenuse 1. By the Pythagorean theorem, we would find out that adjacent is going to be the square root of 1 minus x squared. No, you can't simplify that. No, it's not 1 minus x. And then for angle v, pretty much same idea, same Pythagorean theorem work, just x right there. So, sine of u plus v is the sine of u, that's this one, x, times the cosine of v, adjacent, hypotenuse, that's also x, plus cosine of u, adjacent, divided by hypotenuse, times the sine of v, opposite, divided by hypotenuse. All right. X times x is x squared. Multiply these, we get 1 minus x squared. Simplifies to be 1. Example number 5, verifying an identity. Verify the identity that the tangent of x minus pi is equal to the tangent of x. We should already understand this one based off of the graph of tangent of x, which has a period of pi. So we shift everything right pi units. It's going to coincide. Let's see if we can prove this and verify it algebraically. Remember our formula, we're talking about tangent of u minus v. So tangent u minus tangent v over 1 plus the product of the tangents. Now tangent of pi, we know that one. The tangent of pi being straight left. Think of the coordinates, think of y divided by x. That's 0, that's 0. So tangent of x minus 0 is tangent x. This all disappears by the product. Divided by 1, don't need it. We're left with tangent of x. We just verified it. Example number 7, solve a trig equation on the interval 0 to 2 pi. Got this equal to 1. That's usually not very friendly. We'd like it to be 0, but if we subtract 1, we're going to create 3 terms over here. And it's not factorable, so getting it equal to 0 probably not helpful. Let's see if we can just work on this side and do some simplifying. Notice that we have a cosine u plus v situation and a separate cosine u plus v situation. Let's work it out by the formulas. So here's our first one, cosine u cosine v minus sine u sine v plus, same thing here, cosine u cosine v plus, that's minus plus sine u sine v, all equal to 1. Let's see what happens. Well, what's the cosine of pi over 2? Straight up, that's 0. Sine of pi over 2, straight up, that's 1, y-coordinate. Cosine of 3 pi over 2, straight down, 0. Sine of 3 pi over 2, straight down, that's negative 1. So let's replace the ones that we know. 0, 1, 0, negative 1. And if we do that, since this is 0, that whole thing disappears. Since this one's 0, this whole term disappears. We just have this one and this one. A negative sine x times 1 is negative sine x. Positive sine x times negative 1 is another negative 1 sine x. Negative 1 sine x, negative 1 sine x makes negative 2 sine x. Since we're just down to 1 sine x here, there's no need to be getting it equal to 0. Let's just divide both sides by negative 2. where in the unit circle is the y-coordinate -1/2. It's not going to be down in quadrants 3 and 4, so it's going to be long going left, short going down. So I think we're talking about 7 pi over 6 and then 11 pi over 6. That's it for today. See you next time.